Welcome back everyone to Data Science for Everyone. Today we're going to be talking about logistic regression with PySpark. Now first off, we need to actually have a little bit of an update. There has been an update to Apache Spark. Okay, we are now on 3.0.2. And so for those of you that have always been following along, we need to actually do a little bit of an update, okay, to our file. All right, so particularly our preamble. Now our preamble used to have 3.0.1. So we need to go on and change that in a couple different places here. Okay, so make sure and change it here at this Spark 3.0.2, 3.0.2, here as well as 3.0.2, and then here as well. I may take some time out in the next week or so to write up a nice little program up here, and I can put it on GitHub for everyone so that we can just have it automatically update as we go along. So that is just a little bit of an update here that I'm going to add in. All right, so let's get started with logistic regressions. So the first thing that we need to do, just like with our linear regression or anything else, we need to make sure from PySpark .sql, we want to import our Spark session. And then we need to create a Spark instance here, our Spark session itself. And so we're going to use the builder. We want to make an app name, and we want to name this, I'll just call this logreg here, and then we will .get or create. Now for the Spark session, we're going to use the example data set that we used with the linear regression in the first place. And so we'll call this df is equal to our Spark session. We want to read, and our format is going to be that pre-made libsvm format. And we need to load that, and we also need to we'll call, and it's called what? Sample lib svm data.txt. Let's run that and let's double check that let me see what error it had here. Oh, see here, I put this out wrong, svm. And let that run. It may take a second here. And again, this data set is available actually on their website. Okay, if you guys want to download that, and I'll put it up on the GitHub page. I believe there's actually even a copy of it on the GitHub page now. Okay, so for downloading this, let me just put in the code here, and if we do something like !curl, and then we put in the website. This is actually their Apache Spark's GitHub page, and this is the location of that data set, and we'll put it in to sample libsvm data.txt, and I'm going to actually call this -2 because I already have it on here. But if we run this, whoops, and again, my fingers are moving in the wrong way today, so here's curl. So, and you can see here that it downloaded it, and it's now here. So when you want to download any of the data sets, okay, I will put copies in my GitHub page, but a lot of the times I'll try and also put in the raw for where I actually got the data as well. So again, this is just using curl, and now this double arrow bracket is to actually make a file, and we can put whatever name we want in here. You can even just name it blah.txt, and it'll be the same. But I usually will always keep it the same name that the data that I'm downloading. So once we have downloaded the data, okay, so now we have our data frame, so we can do something like df.print schema, and let's take a look at the data. Now, again, since this is already in that optimized format for us, it's fine. You can consider this just the training data. I'm not going to actually probably do any splitting on this particular data set because, again, it's just already kind of the training data that you would be using. But let's go on and create a logistic regression. So from PySpark.ml.classification, import logistic regression. And then let's make sure and instantiate the model for logistic regression. And I'm going to just do model is equal to lr.fit. And again, we're going to do this on the whole data set for now. And then let's say summary is going to be our model dash summary. And I'm just going to run this all in one. It makes life just a little bit easier, and also because I don't want to have to run them multiple times. Now then, we can also take a look at our summary.show. Oh, let's actually grab the predictions. And here we can see that we have our predictions. We have the probability of our predictions. We have our raw predictions themselves, and we also have the features as well as the label. Now, from here, we need to also make sure that we double check our work. Okay, so we need to make sure and evaluate. Now, I am not 100% sure if this still works here, but we will look and see. And so we want multi-class metrics. And so then let's do model.evaluate. And then here we want our data frame. Okay, that puts that out. Okay, so that works. All right, and then we want to also make sure, and we're going to just actually save this, okay, instead of just shooting it out here. So let's do something like predictions, pred, and labels. And we'll save that in there, and then we will actually grab our predictions and our labels here, and we want to do predictions.show. And again, we see here we get the same result as if we did with our summary. Okay, it just, again, this is just another way that we can take a look at it. Now from here, we want to grab just our label and our prediction so that we're going to be able to compare the two. So let's say we want our predictions and our labels, and I'm just going to overwrite this. Predictions and labels dot predictions, and then we want dot select, and we're going to grab the label and we want prediction. Our prediction and labels, we show them, and here we see again we have both our predictions and our labels. Now once we are in this format, okay, it's going to be a lot easier for us to be able to do our classification evaluations. So now we want to properly do our evaluation. Now there are a couple different things that we can do, but let's just go and do the basic evaluation. So from PySpark.machineLearning.evaluation, import, and then now we are currently doing a binary classification. So we want a binary classification evaluator. We can also do a multi-classification evaluator. So we'll need to instantiate an evaluator. Now again, for those of you that don't remember what binary means, it means either a 0 or a 1. Okay, so it is, and that's what we're actually doing here for our predictions. Here you can see that they are 0, our labels are 0 or 1. So on, off, dead, alive, something that has a binary in its meaning, okay? So then we need to make sure and take a raw prediction column here, and we give it our prediction, and then we have our label column, and that is going to be here label, and we'll allow it to be eval. Now we can also do this also for example, for our multi-class one as well. But let me just show this real quick. Eval, let me run it. And notice here that it just has this instantiation metric here. But if we do something like dot evaluate, and let's do predictions and labels, and we run this again, it's just going to give us out how accurate that is. But now, for example, if we do multi-class, let's actually overwrite this. And you know what? I'll actually make it another one. Multi. And so our multi-class classification evaluator, again, it's going to work the same way. So we have our prediction column, and it's going to be prediction. And then we have our label column, and that's going to be label. Whoops. And then let me actually make this a little bit cleaner here. Now, the next thing that we actually need to make sure of is we have a metric name in here, and this is where it's going to be a little bit different, and we want to do the accuracy. And so if we create our accuracy measure, evaluate here, and we want our predictions and labels, we can also do this and double check. And our accuracy, again, is 100%. Now, if you ever really see this in the real world, okay, that means you probably did something wrong. You were definitely overfitting your model. But again, since this is a fake data set here, then that's completely okay. So let's go on with another example for logistic regression. Well, let's use the Titantic data set. Now, let's go on and assume that we had not currently run any models or anything else. So let's assume we have a brand new sheet. So from PySpark.SQL, we want to import a Spark session. Okay, and I'm going to overwrite, Spark session. And then let's also make sure and overwrite Spark itself. So let's do a Spark session dot builder dot app name, and I'm going to call this Titantic. And then we want to again get or create. Now from here, let's say df is going to be our spark.read.csv. We want Titanic.csv. Now remember, now since we are using a a proper data set, we're also going to have to start transforming the data as well. So let's infer our schema to be true. We want our header to also be true. We'll run that, and we will, that's because I misspelled Titanic. There we go. My fingers are definitely not working today, guys. So let's see here. Now let's make sure and check if our schema is correct. So we have passengers, which is an integer, are survived or died. This is going to be our label. Okay, we want to predict this. Our P class is an integer, names are strings, sex is a string, age is a double, sibling spouse is an integer. Patriarchy stuff is an integer, their ticket is a string, their fare is a double, their cabin is a string, and their barked is a string. So let's make sure that we have a full list of our columns that we can mess around with, and we'll use this to kind of copy and paste what we actually want to select out. So let's make a, let's call this, I'll call it initially features. Or you know what? No, let's just call it data, because this is actually what we want to use. So df.select, and here we want what? We want them to survive, and P class. You know, I'm going to actually just copy this whole thing, and then I'm going to delete what I don't want. So we don't want passenger ID. We want P class. We don't want their name. We want their sex. We want their age. We want sibling spouse. We want the patriarchy. Let's delete the ticket. Again, right now what I'm doing is I'm deleting the, again, based on this and based on my knowledge of the data set, I'm getting rid of things that I know are going to be a little bit troublesome for us to deal with. Fair, okay. Cabin is okay to delete, and then we'll keep embarked as well. Now, the reason I got rid of these others because this cabin, for example, actually has very similar data in it that would, for example, their fare. Their fare actually holds a lot of information because, again, it shows kind of like how much their wealth is and whatnot. We actually also wanted to get rid of this passenger ID and their name because they're strings. We could do some sort of natural language processing with those things, but again, that's beyond the scope of this particular series, and we'll work on that a little bit later. So let's go on and run this. And we'll select out our data. And again, let's go through and make sure that we data, and I'll call this final. We actually need to drop NAs, okay? We did not, there are NAs in this data set, so we want to make sure and clean that data. So, and we do that with the data na.drop, and I can, let me see if this will give us some dot head. So we can actually see what type of information that looks like. So here's the row that it would look like. So again, it's nice clean data now that we can play with, and we do not have any missing data anymore. So now let's start working with categorical data. And let's go through and do something like from PySpark.ml.feature import, and here we want the vector assembler. We want a vector indexer. We want one hot encoder, and we also want a string indexer. Now, the reason that I use this these parentheses here is that I wanted to make this on a double line. Otherwise, I was going to go too far, and I'd have to scroll. So if you want to do multi-line imports, you can use these parentheses to assist with that. So next up, let's deal with the gender. And we need to make a gender indexer. So we'll use the string indexer, and our input column is actually going to be sex for this. And then our output column here, we want this to be, let's call this a sex index. And then we want our gender encoder. And this is going to be our one hot encoder. And then our input column for this is going to be our sex index. And then we also want to have our output column here to be, let's call this sex vec. And then we also want to have the same thing, embark, indexer. And again, what I'm going to do is actually just copy this and put this in here. And instead of gender, we're going to change this to embark. Embark, and then we need to go through and change each of these as well. And so here we want embarked, and then this is going to be embark, embark, embark. And that works for both of our string features. Now the next thing we need to do is create our assembler. And that's our vector assembler. We want our input columns here. And our input columns are going to be P class. P class, we want the sex vector. We want here age. Oops. Age. We also want sibling spouse. Oh, and that needs to be a string. And then let me clean this up just a little bit in here. We want P arch, we want fair, and then we want our embark vector. And then we also have our output column is going to be features. And let me put this on a new line here. Put features, whoops, and run that. Oh, and what did what did I miss here? Oh, whoops. Okay, so I accidentally put this inside of the list. So notice here, this is input calls, and it takes a list. Okay, and this is input output call, singular column, and that will give us our features. So again, our singulars. So in here, so for example, here you see input call, that is embarked. Output call here is again embarked index. So again, we have the column singular is going to be a string input, but if you have an S in here for input columns, you need to make sure and use a list. Rerun that, and that will get rid of our error that we have in there. Now the next thing we need to do is make sure to actually do from PySpark.ml.classification import logistic regression. Now I know I already imported it from the first example, but I'm reiterating here so that we know that we need to grab it. And the next portion that we need to go in here is actually very important in inside of PySpark, and that is pipelines. So from PySpark.ml, we want to import pipeline. Let me see how I'm doing on time. Okay, we're doing fine on time today, going pretty quick. So now when we're looking at this, we need to make sure and do, so let's do our linear regression. Now we want our logistic regression. You know what, I'm just going to do this as LR. I don't like to have everything too long. Now from here, we need to make sure and have our feature columns, or a feature column in this instance. And again, it's going to be features. Okay, and that is named from up here. I'm going to delete that too. Okay, and I'll keep that up there. And then the next portion that we also want in here is our label column. And again, this is going to be, what did we have in here? We want survived. Okay, so we instantiate the model. Now we need to create the pipeline to utilize all of our vector assemblers and our indexers and our encoders. So now we create our pipeline here, and we create pipeline, and here we have our stages of our pipeline. And this is going to take a, whoops, this is going to take a list. Okay, so we just put in our gender indexer, our embarked indexer. In here we have our gender encoder, and again I misspelled encoder, but that's fine as long as I know. And then we have our embarked encoder. Let's put this on a new line for each of those. And then we want our assembler, and then we want our linear regression model. Now what this is actually doing, this pipeline is just telling us how we want to run all of this stuff. Again, none of our indexers, none of our feature assemblers, none of our one-hot encoders, none of this stuff has been run yet. We've just been instantiating them, and then we are kind of waiting for everything, and it's going to just, Spark will do it all at once for us. So then we come back down to our pipeline and we say, this is what we want to do. We want you to do it in this order. Okay, it's not, if you put these out of order, it's going to give you an error, okay, because it doesn't really know what you want to do unless you give it its instructions. So think about this as the recipe for your linear regression, or your logistic regression in this instance. And we will, the more we move on with the series, we'll be using these pipelines more often, so make sure you get a little bit familiar with it. Now the next thing we want here is our training and our test data. And so we have our data final, in here, and we're going to do just a random split, and we want this to be 0.7 and 0.3, and then our seed here is going to be 42. And so let's fit our model. Let's just do model fit, and this is going to be here. We want our pipeline dot fit, and we want our training data. Then we'll also have our results here, and that will be our model fit dot transform. And then this is with our test data. And again, I could have changed these up to xtrain, xtest, or but again, I'm just using them as train and test for these purposes that we have in the class. So now let's take a look at our results. And from here, we want our from PySpark.ml, and we want our evaluation metrics in here. So from, and we want a binary classifier evaluator, because again, this is survived or died. Okay, it's 1 or 0. And then let's have our evaluation here is our binary classifier evaluator. We want our raw prediction column, and that is going to come out as prediction. And then we also want our label column, and this is going to be survived. Run the, whoops. And here I accidentally had a minus sign instead of an equal sign. All right, and then let's take a look at our results dot select. And here, let's make sure we take a look at our survived and our prediction. Whoops. Let me see what happened here. Oh, whoops, prediction. There we go. Okay, so again, here we can probably see that it's probably not going to do too well. All right, just looking at it. So let's actually run the evaluation and see. We're going to do the AUC curve. So we want our evaluate, and here let's look at our results. Running, and let's look at the AUC for our results. And we see that we're getting about a 77% accuracy. That is not great, but it's not bad. Again, if we maybe fine-tune our model, we do a little bit more of some data cleaning, maybe we use some other of the string values, we can probably bring that up. We can also see maybe if there's some interaction that's happening with some of the data and whatnot, but overall this is really not too bad as an initial result. Thank you guys so much for watching. If you like this, please comment, subscribe, and leave a comment. Thanks. Bye-bye.